Hello, everyone, and welcome back to another episode with your girl, Audrey Codner-Gibson from ACG Math Tutoring. How are you guys doing? I'm still keeping up with this whole Algebra 1 foundation skills. Hopefully you are too. Okay, everyone, so today we are going to work a little bit more with that Pythagorean theorem, but with a twist. We're going to do what's called the distance formula. So we're going to measure the distance of 2 points by using this simple formula, which has a little bit of similarity when it comes to the whole Pythagorean theorem. So we're going to look at Common Core standards A-APR 0.7 and A-REI 0.2. So let's do a review of that Pythagorean theorem, that a squared plus b squared equals c squared. So we're going to find the missing side. So in this case, it is b. So my longest side, if you recall, is always directly opposite of my 90-degree angle. So my c is going to be 12. So my a, which we indicate is going to be 4. So we got 4 squared plus b squared equals 12 squared. So now 4 squared, do not say 8. Remember, 4 squared is that base of 4 being multiplied by itself 2 times, meaning 4 times 4, which gives me 16. Bring my plus and my b squared down. Now my 12 squared, that's 12 times 12, which gives me 144. So now I'm going to subtract 16 on both sides because we're trying to isolate that b. So right now, the b is a square. So now when we do our subtraction, so we're going to borrow, just kind of get used to that. So we got 120 and we have 7 eighths. Okay, so we got 128. So now we're going to do the inverse of square, which is the square root. So that square and that square root, they cancel each other out. So now we have b equals the square root of 128. Now, could we leave it like this? Of course we could, but we always want to get it down to the simplest form. So if I have my 128 and I start seeing if I can break it down. So I got to think of that perfect prime combination. So if my prime is 2, my perfect is going to be 64 because 64 times 2 gives me my 128. So now the square root of 64, that's going to be 8. And the square root of 2, since that's prime, I'm just going to bring that on down. So normally, if we're solving and it deals with the square root, we always do the positive and the negative. But it doesn't make sense to have a negative because you can't have a negative length of side. So we're just going to focus just on the positive aspect, which gives me 8 square root of 2. All right, so that's the length of that missing side. So what we're going to do for today, you should be able to say, I can calculate the distance between 2 points using that distance formula. So again, we're going to be looking at the guided notes and examples. We're going to be looking at the practice problems, and then we're going to finish off with our exit ticket. So here's the formula for distance. So if you notice, it kind of looks a little bit like slope. It kind of has a little flavor of the Pythagorean theorem because you got the square roots and the squares. So it's really looking at the difference of your x and your y values. You're going to square it and then get the square roots of that. So that's why you have the square root of x squared, x, the second x, minus x to the first one. Square that plus the difference of your y's and square that. So a couple things that I think it'll be a lot easier to do this. First, label your points. Okay, label each of your points, your x1, your y1, your x2, your y2. So you can substitute it into this formula. So you're really going to have to understand this formula, okay? Once you substitute it in, then you're going to simplify your answer. So let's look at a couple examples. So we have find the distance between -2, 1 and -5, -4. So since -2, 1 is my first point, this is going to be my x sub 1 and my y sub 1. 1 meaning the first point. So since this is going to be my second point, this is going to be my x sub 2 and my y sub 2. So notice all I have to do is plug it in to our formula. So my x sub 2, that's -5. -5 minus my x sub 1, which is a -2. Then we're going to square that. Then I have my y sub 2, which is -4, minus my y sub 1, which is 1. And then we square that. Now, we are going to simplify. Remember, anytime you simplify, you always work from the inside out. Remember, PEMDAS, okay? You need to work what's inside the parenthesis. So I'm going to rewrite my square root. So now I'm going to have inside the parenthesis, -5 minus a -2. Remember, when you minus a negative, it's actually going to turn to a positive. So we got -5 plus 2, which gives me a -3. -4 minus 1, both of them are negative. So we're going to add them together and keep the sign, which gives me a -5. So now we're going to square it. So -3 squared, that's the same as saying -3 times -3. So that gives me 9. Plus -5 squared, that's -5 times -5, that gives me a positive 25. So you see how we're slowly breaking everything down? So now I got my square root again. So we got our 25 plus my 9. So that gives me 34. So now we have the square root of 34. That's going to be the distance of those 2 points. Now, off the top of my head, do I know what the square root of 34 is? No, I don't, especially as a decimal. So if I go to my handy dandy calculator, I have the square root of 34 and rounded, let's say rounded to the 10th place. Okay, I usually kind of like to round to, I'll round to the hundredths place. That's normally where I'm at. So I have 5.830 Okay, so that's what I got in my calculator. But if I'm going to round to the hundredths place, which is right here where the 3 is, I need to look at the next one over. So it's a 0. So remember the old saying, if it's 5 and above, we're going to give it a shove. That means we're going to add 1 to that 3. But 0 is less than 5. So if it's 4 and below, we're going to leave it alone. So my answer for the distance is going to be 5.83, whatever my units are. The reason why I have the graph is if we wanted to graph it a little bit. So here's -2 and 1, which is right here. And we're trying to find -5, 1, 2, 3, 4, 5, and -4, 1, 2, 3, 4. So we wanted to find the distance, how long that distance from both of those points were going to be. So we're looking at 5.5 and 83 hundredths length, whatever the units is going to be. All right, let's try one more example. So now we're going to find the distance of -5, 3. So 1, 2, 3, 4, 5, down 3, 1, 2, 3. So we got this point here. And -9, -6. If I say that this is 5, -5 is going to be off this graph. So as a practice, instead of counting by ones, what could I count by? I could probably count by 2s. I can count by 5s. I can count by 3s. I think 3s might even work a little bit better. So I'm going to say that's going to be -3. This is going to be a 3. This line is going to represent 3, and this line is representing -3. So That means this is -6, so -5 is roughly here, and here's -3, so we got that point. And -9, -6, so 3, 6, 9, and then -6, which is right here. And so I'm looking at the distance between these 2 points. So let's use the distance formula. Since -5, -3, that's my first point, so that's my x1 and my y1. Since -9 and -6 is my second point, that's my x2 and my y2. So now all we're doing is plugging it into the formula. So we have our d, and we got our equals. We're going to rewrite our radical. So then all we're going to do is plug in my difference of my x's squared and my difference of my y's squared. So y2, which is -9, minus my y1, which is a -3. Make sure you represent that negative. It is not -9 minus 3. The 3 is negative. So that's why I put parentheses around it, so I can isolate that -3 just for a moment before I start combining. Then we have our y2, which is a -6, minus my y1. And I screwed up because this is supposed to be a -5. See, I got so worried about correcting instead of just doing. So we got our -3 is over here. Again, both of those x1, y1s were both negatives, so I definitely put parentheses around it, making that correction. So now, when you minus a negative, they turn positive. So this is actually going to turn positive, and these are going to turn positive. So that means you have -9 plus 5. That gives me a -4, and we're going to square that. Plus -6 plus 3. The signs are opposite, so it's going to be subtraction. So that gives me a -3, and we're going to square that. So -4 squared, that will give me 16, because -4 times -4 gives me 16. Plus -3 squared, that gives me 9, because -3 times -3 gives me 9. And then we're going to go into this. So we got our 16 plus 9. That gives me 25. So we got the square root of 25. I think we know the square root of 25. Now, I know most of us will say, oh, it's plus minus 5. But here's the thing. We're looking at distance. So does it make sense for us to have a negative length for distance? No. So instead of worrying about the plus minus, we're just going to write the positive version of 5. Okay? There's going to be times that we have those rules, but we got to look at our situation. If I'm looking at length, obviously I'm going to take the positive. If I'm looking at direction, I got the positive and the negative. If I'm looking at points, I'm going to the positive and the negative. Okay? So the length from those 2 points is 5 units. And I don't know. There we go. All right. So now I want you to practice. Okay? You can pause this and then we can try to calculate some things out, but try to do this on your own. All right. So let's check our answers. So we have our x1, our y1, our x2 sub 2, and our y sub 2. And we're going to plug it into our formula. So we have 4 minus 1, and we're going to square the difference of my x's and the difference of my y's squared. So 4 minus 1, that gives me 3 squared. And 2 minus 1, that gives me 1 squared. So we have 3 squared, which gives me 9, plus 1 squared, which gives me 1. So now we got the square root of 10. So do I know what the square root of 10 is? Nope. I'm going to go to my handy dandy calculator. And this is what I got as an answer. So I got 3.1625. 22766. But I like to round my answers to at least the 100th position. So that's 2 decimal places. So I'm looking at the 3rd decimal place, which right now that is a 2. So since it's not 5 and above, I don't need to add 1 to the 6. So I can keep my answer as 3 1600ths, whatever my units are. Okay, so if you wanted to graph it, you got 1, 1. We got 1, 2, 3, 4, 2. So the length, the distance of those 2 points is 3 1600ths of whatever my unit is. Okay, so that's it. So you should be able to say to yourself, hey, I can calculate the distance between 2 points using the distance formula. Once you know the difference or the distance formula in itself, so you got your square root, you take the difference of your x's, and you're going to square that and add to the difference of your y's, just like how you would calculate in slope, except for you're squaring and you're adding them together. So we reviewed the exit ticket from last time. That was the Pythagorean theorem. We did some guided notes and a couple examples. We did a practice problem. Now, let's get that exit ticket going. So you have one problem and one problem only to find the distance of these 2 given points. So you have 2, -3, and 8 and 7. So if you are new to my channel, welcome. I hope you enjoyed it. Yes, it was very short and sweet, but it was very informative. And if you want some more practice, or if you have any questions or you have any comments, go ahead and hit the comment section and go ahead and give me your comment, because I can respond to you within a 12-hour sequence. All right. So if you want some private tutoring, I'm available for tutoring. You can have me as your tutor to help you with your guidance through those whole algebra foundations. So if you enjoyed this, please like, subscribe, and share. Don't keep it to ourselves. Let me show out there all you want. So as always, thank you so much for joining in, and hope to see you next time. Take care.